In the last chapter, in force, you got to know what is force, what is the magnitude of force, how can we find the magnitude of force. Now, we are in the position that we can define work, or we can get to know about work. What is work? So basically, in our day-to-day life, whatever we do, if we are writing, we are singing, we are dancing, we are doing anything, then we say that we are doing our work. But in the language of physics, in science, we say that work is done. It is said that work is done on any body only if you apply a force to the body and the body starts to move. Such as, I have this marker over here. I apply some force to it and it starts to move. Then we say that I have done some work on this marker. But if I am exerting a force on this board or on the wall behind it, it is not going to move anywhere, it is not being displaced. So in physics we say that no work is being done by us. Why so? Because we are applying the force on the wall or on the board, but it is not moving at all. There is no displacement produced in it. So we say that no work is being done. So basically, if you are asked that what is work, if a force is applied or is exerted to a body and it starts to move, or we can say that displacement is produced in the body, then we say that work is done. So this was the theoretical part about work. But if you are asked to define it, if you are asked to define any physical quantity in your board's exam, then you won't only state this theoretical part. If a force is applied to the body and the body starts to move, or you can say that there is displacement produced in the body, then work is said to be done. Along with the theoretical part, you have to conclude that what is the magnitude of force. If you are asked that what is the magnitude of force, then we are denoting work by this symbol, that is W. Work, the magnitude of work done can be found by multiplying the force that is applied to the body, that is exerted to the body, and the displacement. We are denoting force by capital F and displacement by S. And the displacement, the force will be applied by the displacement produced in body. And the most important part, you have to mention the direction of the displacement. The displacement produced in the body, it should be in the direction of force applied. So this was about the definition of work. Work, what is it? If force is applied to the body and the body starts to move, then work is said to be done. And the numerical part, you have to mention the formula of it, the expression for work. That is, how can we find the magnitude of work? By finding the product of what? The force applied to the body and the displacement produced in the body. In which direction? In the direction of force applied. But it is not necessary that the displacement produced in the body will always be in the direction of force applied. There are some conditions, some cases in which you are applying the force in any direction, in one direction, but the displacement produced in the body is in some other direction. We can say that the displacement produced in the body, it makes some angle with the force applied. Such as, we will look for an example. Suppose we have a block here that is placed on the inclined plane. This is a simple machine, you will get to know about it. Inclined plane. Inclined plane, we use it to do our work simpler, to make it simpler. Here we have a block over here, and you are applying a force, capital F, on the block, and obviously you can see here the direction of force is in this direction, is horizontal in direction. But what about the displacement of the block? It is not possible that the block will go inside the inclined plane. Obviously, the displacement of the block, it will be in this direction, along the inclined plane. So this is our displacement. What do we observe? Force is in this direction, in horizontal direction, but displacement is in this direction. So according to our definition, the displacement produced in the body, it should be in the direction of force. Then only we can apply this formula. We can use this expression. So we have to use the simple concept of trigonometry that you have learned in mathematics. We suppose the angle between the force applied, the force is being applied in this direction, in horizontal direction. The angle between, suppose this is the direction of force. The angle between what? The angle between the force being applied and the displacement. This is our displacement. So the angle between the force and the displacement, let it be theta. So what can we do? We will find the component. Component means the part of anything. So we'll find the component of displacement in which direction? In the direction of force. And for that, what can we do? This is our displacement, that is S. Obviously, it is 90 degree, it is right angle. This is theta. So what can we do? We have to find the component of displacement in which direction? In the direction of force. It means that we have to look for this part. So this is x. Applying trigonometry, this is x. Then what will be this part? This will be, you know about the relation of cos theta. Cos theta, it is equals to b by h. Suppose that we don't know about this b. B by h, that is the hypotenuse, and we know the value of hypotenuse, that is s. So what will be the value of b? S cos theta. So this is our b, this length is b, and it is in the terms of displacement, this b will be equals to s cos theta. It means that we already found the component of displacement, the part of displacement, in which direction? In the direction of force. This is our direction of force, and now in this condition, this s cos theta, the displacement is also in the direction of force. So we can use our expression, that is for work done. What is work done? It is the product of force and the displacement produced in the body in the direction of force. So we have the force over here, and what is the displacement produced in the direction of force? This is not s, this is in the direction of force is s cos theta. That is the component of this displacement, this s. So we multiply it with what? Not with s, because this s, it is not in the direction of force. Force is in this direction. And this s cos theta, we found a component of s cos theta in the direction of force. So we write it over here. That is cos theta. So finally we got the expression for work done, that is Fs cos theta. Now it is the generalized equation. It might be possible that the angle between the force and displacement is 0, it is 90, it is 180, it can be anything. It can be of any magnitude. But you can use this expression in any condition, that is W is equals to Fs cos theta. Now we will be talking about the SI unit of work. The SI unit for work is joule. Again the same part. If you use the symbol only to represent it, it will be capital J. Otherwise, it will be starting from small j. So the SI unit for joule work is joule. If you are asked to define that what is 1 joule, what is 1 joule of work done, how will you define it? I told you earlier in the last chapter that if you are asked to define any unit in physics, what do? You firstly write the expression, the formula for that physical quantity. Such as we are being asked to define 1 joule. You know that joule is the SI unit for what? For work. So the very first part, it would be, we will write the formula for work. What is it? F S, F into S. 1 joule. 1 joule of work. Obviously joule is the SI unit for work. So we will take the SI unit for these quantities also. For force, and remember it. The magnitude over here is 1, is unit. So for rest of the physical quantities also, we will take the magnitude to be 1 only, to be unit only. As you know, the SI unit for force is Newton, and for the SI unit of displacement, that is the length, is meter, 1 meter. Now you can define it of your own. What do? If you apply a force of 1 Newton to a body, suppose here is the body, you apply a force of 1 Newton to the body, and the body, it is displaced by 1 meter. This is our displacement, that is of 1 meter. Then you say that the work done by us is of 1 joule. It should be very clear to you. You apply a force of 1 Newton to any body, and the body is displaced by how much? It is displaced by 1 meter. Then you say that the work done by us is of 1 joule. Now you have the SI unit here, that is joule. If you are asked that what is the CGS unit of it, CGS unit of work, the CGS unit of work is ERG, E-R-G. It has no symbol. ERG, E-R-G. It is the CGS unit of work, and joule is the SI unit of work. Now, the relation between the SI, you might be asked that what is the relation between SI unit and CGS unit of work. So it is 1 joule, that is the SI unit of work, 1 joule is equals to 10 to the power 7 erg. It is the relation between SI unit of work and CGS unit of work. SI unit, joule, CGS unit is erg. So 1 joule is equals to 10 to the power 7 erg. Now, there is no need to memorize it, that it is the relation between joule and erg. 1 joule is equals to 10 to the power 7 erg. You can do it of your own. How? 1 joule is equals to 1 Newton into 1 meter. You know about the SI unit of force and the CGS unit of force also. The CGS unit for force is dyne, and 1 Newton is equals to 10 to the power 5 dyne. That is the CGS unit for force. And what about displacement? For displacement over here we have the SI unit of displacement, that is meter. And we will use here the CGS unit of displacement, that is the CGS unit of length, that is centimeter. So 1 meter is equals to 100 centimeter. What do you observe? 10 to the power 5, 10 to the power 2. It is 10 to the power 7 dyne centimeter. So this dyne centimeter, it is only replaced by the unit, that is erg, that is the CGS unit of work. So here is the relation for joule and erg. 1 joule is equals to 10 to the power 7 erg. Now, as you know about the units of work, the SI unit and the CGS unit of work, now we are moving towards the special case. Some of the special cases here. We have the first case. Now, so firstly, we will write the expression for work, that is W is equals to Fs cos theta, where theta is the, you know about theta. What is theta? Theta is the angle between the displacement and the force. Now, the first case, case 1 is theta equals to 0 degree. Theta equals to 0 degree. What does it mean? There is 0 degree. The angle between force and displacement is 0 degree. What does it mean? That the force and the displacement both are in the same direction. There is no angle subtended between the force and the displacement. Suppose if you hold a ball over here and you leave it, as soon as you leave it, what do you observe? The ball, it starts to fall down. It starts to go towards the surface of earth. So why does it move in downward direction? You know the reason why. Due to the force of gravity, force due to gravity. So the force is acting in downward direction. The force that is exerted by the earth on what? On the ball. The force is acting in, the force due to gravity is acting in downward direction. And the ball, it also moves in downward direction. What does it mean? The force and the displacement, the force exerted on the ball by earth and the displacement of the ball, both are in same direction, both are in downward direction. Force in downward direction and displacement of the ball in downward direction. So both of them, F and S, both are in same direction. Here we have the ball over here. It falls freely under gravity. It was here, suppose that it is at a height h. As soon as you leave it, it starts to fall in downward direction. It starts to move towards the surface of earth. This is our earth's surface. So it starts to move in downward direction. The force due to gravity, it is acting in downward direction, and the displacement of the ball, it is also in the downward direction. So the angle between force and displacement is 0. So what will be the work done? Work done by what? Work done by force due to gravity. Force due to gravity, simple. In simple words, what is force due to gravity? It is the force exerted by earth on any body. It can be on any body, on the ball, on the fan, on the tube light, on this board, on this marker, on me, anything. So force due to gravity, we have the value. We assume that the force due to gravity exerted on the ball by earth is capital F. S, that is the displacement. Suppose the displacement of the ball is h or s, anything. And what about this theta? The theta, the angle between force and displacement, both are in same directions. So the theta is here is 0. And as you know, cos 0, it is 1. So what is it? The work done here will be directly the product of force and displacement, because the displacement here, it is in the direction of force. So it was the first case. Now we are moving towards the second case. The case 2 is theta equals to 90. What does it mean? The angle between the displacement and the force, the angle subtended between the force and the displacement is 90 degree. Firstly, we will look for some examples. As a body, it is moving on a circular path. In the last chapter, we got to know about what? About force, about centripetal force. So in this case, whenever a body is moving on a circular path, whenever a body is performing circular motion, what is the responsible force? The force that is responsible for this circular motion, it is centripetal force. You know about it. So the centripetal force, it is acting towards the center of the circular path. But what about the displacement of the body? As you know, displacement or velocity, all of these physical quantities, these are vector quantities. So the displacement of the body, suppose the body is over here, so the direction of motion, the displacement will be in this direction, that is along the tangent. And in maths, you got to know that the angle between a tangent and the radius of the circle, it is 90 degree. Or we can say that if you join the center with the point of intersection of tangent with the circle, then the angle is 90 degree. So here theta is 90. So in this case, the work done by this centripetal force, what would it be? The force is acting in in this direction towards the center, but the direction of motion, the displacement is in this direction. So the angle between the force and displacement is 90 degree. So in this case, the work done by the centripetal force, it will be, suppose the centripetal force, it has the magnitude capital F, and the displacement of the body, we denote it by S. What about the angle? The angle here is, theta here is 90 degree, and you know about it, cos 90 is 0. So Fs, it doesn't matter that what is the magnitude of force, what is the magnitude of displacement, cos 90 here is 0. So obviously this part, the whole part, it means the work done by the centripetal force, it will be 0. One more example, it's very common example. If you are asked, it might be possible that you are asked in your boards exam or in your school exams, that if a coolie, he is moving with a load over his head, the coolie, he has a load over his head, and he or she is walking on the surface, on the floor, then is he doing some work? What is the answer? No. There is no work being done by the coolie. Why so? Because as I told you earlier, in physics, in science, we say that work is done only if force is applied and the body moves. There is displacement produced in the body. Now, when the coolie, he lifts the load up, then obviously he is exerting force in upward direction, and the load, the luggage, is also being displaced in upward direction. So at that instant of time, he was doing work. But at that very moment, when he starts to walk on the surface, on the floor, then he does no work on the load. Why so? Think. Why so? It's very simple. He exerts the force now also when he is walking on the surface. Now also he is exerting force in upward direction. He is exerting force on the luggage in upward direction. But the load, along with the coolie, the load is also moving in this direction. That is in horizontal direction. So the displacement of the load, it is in this direction, in horizontal direction. But the force applied on the load is in upward direction. So what is the angle between them? Force in upward direction and displacement of load in horizontal direction. The angle between them is 90 degree. So it doesn't matter that the coolie is lifting it up or he is moving on the floor, he is walking on the floor, he is doing no work in physics, in the language of science. So these were the two cases. Now we move to the case 3. Case 3. When theta equals to 180 degree. Firstly, we will look for some examples, such as in case 1, we talked about the work done by force due to gravity. In the case when we throw a ball in vertically upward direction, or we throw any object in vertically upward direction, what do? We apply force in upward direction, and the ball also moves, or the body also moves in upward direction. So in this case, we are doing some work on the ball. But what about the work done by force due to gravity? Think over it. You threw the ball in upward direction. The ball is moving in upward direction. But the force due to gravity, it will be acting always on the ball, on any body. So the force due to gravity, it is acting on the ball in downward direction. But what about the displacement of ball? What about the displacement of the ball? The displacement of the ball is in upward direction, but the force of gravity is acting in downward direction. So in this case, as you can see, the force in downward direction and displacement in upward direction. So both of them are in opposite directions. So what is the condition? The force due to gravity is acting on the ball in downward direction towards the surface of Earth. But the ball, it is moving in upward direction. So the displacement is in upward direction and the force is in downward direction. So what is the angle subtended by them? It is of 180 degree. So in this condition also, using this expression, W is equals to Fs cos theta. F, that is the magnitude of force, S, it is the displacement of the ball, and the angle, the theta here is 180 degree. Cos 180 degree. it is -1. You will get to know about it in mathematics. Fs cos 180 degree is -1. So what do we get here? W is equals to minus Fs. So in this condition, the work done is negative. Work done by which force? Work done by force due to gravity. Work done by force due to gravity. In this condition will be negative. Now we compare both the cases. Case 1 and case 3. In case 1, we took an example that the body, it was falling freely under gravity. Force and displacement both were in same directions. So the work done by force due to gravity in that condition was positive, was F into S. But in this case, in case 3, the work done by force due to gravity is minus Fs, is negative. Why so? Because the displacement is in upward direction and force due to gravity is in downward direction. So these were the special cases for work being done by any of the forces. In the next part, in the next topic, we will get to know about energy.